Section 17.1, electric charge. The objectives here are to understand the basic properties of electric charge, to differentiate between conductors and insulators, and to distinguish among charging by contact, induction, and polarization. Let's first start with the definition of what the electric charge is. And simply put, the electric charge is occurring when a material has more electrons, either negatively charged, or fewer electrons, positively charged, than in its neutral state. So every material has a neutral state. If there is an abundance of electrons, it's negatively charged. If there is a lack of electrons, it is positively charged. Now, some examples of this are things like spray paint, hair products that have static electric charge to them. And we'll make a note quickly that like charges of different objects repel while opposite charges attract, and electric charge is conserved. The next major idea is that electric charge is quantized, meaning that it is on some multiple. For example, objects have 1, 2, 3, 4, 5 electrons. They don't have parts of electrons. They're quantized. They're integer values of electrons. And this was discovered by Millikan in his famous oil drop experiment, where drops of oil were dropped between two charged plates, one positive, one negative, and they would eventually be suspended in air based on the amount of voltage put across those plates. And what that allowed them to do was to calculate the amount of charge of each of those oil drops that was ionized with a certain amount of electrons. And what they realized was that each of the charges were multiples of this number right here, 1.6 times 10 to the negative 19, which meant that every electron must have this charge. Every electron must have this charge because the total amount of electrical charge on these oil drops were all multiples of this number, which enables us to realize that as we alter the amount of voltage, it also alters the electric field produced to hold that piece or that drop of oil suspended in air between the charged plates. And that allows you to realize that every little change of voltage, which is the change in the amount of electrons through there, was also altering the size of the oil drop that was there. And the size of the oil drop mattered because the bigger the oil drop had more electrons to it. And one thing that we should note is that the electron charge is really negative 1.6 times 10 to the negative 19 coulombs. This is really called the elementary charge. The elementary charge of a particle. This is really the charge of a proton. An electron is negative 1.6 times 10 to the negative 19 coulombs. And as you can probably guess, the charge on a neutron is simply 0 or 0 elementary charges. Now let's quickly discuss the difference between an insulator and a conductor. An insulator is a material that does not transfer charge easily. For example, like rubber gloves. You wear rubber gloves when you work on electrical work in your house because if you touch a wire that happens to be live, meaning there's electrons running through it, you don't get electrocuted because of the rubber. It's an insulator. It does not transfer that charge. Glass, plastic, many things. Now, conductors are materials that transfer charge very easily, and mainly these are metals. Most metals are really good conductors. Now, we should also note the fact that there are things called semiconductors that are traditionally insulators, but by the addition of different specific atoms, they can become conductors. So silicon and germanium are examples. And then superconductors are certain metals that become perfect conductors when they're below a certain temperature, or you can assume they're perfect conductors. And what that means is there is absolutely zero resistance in the material. Now let's take a look at our first mode of charging, which is charging by contact. And the way charging by contact works is when an insulator is charged by contact. Again, an insulator. For example, if you rub a balloon against your hair, it gains a charge in the area of contact. And what's happening really is that your hair, the electrons are jumping from your hair to the actual balloon there. So your hair becomes positively charged and the balloon becomes negatively charged, which is why you see them attract each other. When you move the balloon away from your hair, it pulls the hair with it. Now for conductors, though, if you charge this by contact, the conductor is going to readily transfer that charge to any other conductor it's in contact with. So for example, if you're holding the conductor and you try to charge it, the charge of it is going to transfer into your body and then into the earth. That's what's called being grounded. The earth is a huge conductor of electricity. So suddenly, if that charge goes into your body, it's going to want to travel into the earth, a bigger sink in a sense, and it'll cause you to get electrocuted pretty much. But if you were wearing rubber gloves, right? If you're wearing those rubber gloves, then it would charge the gloves, but it wouldn't actually charge you. Okay, it could charge you by insulation, but it's not going to transfer through the gloves into your body. Now, the second mode of charging is called induction, and this is a little bit different. The way induction works is as follows. You charge a conductor this time instead of a insulator, and the way you charge a conductor is that you don't ground it, meaning you let the conductor sit right here, this piece of metal, for example, okay? So this is a glass rod that's been charged negatively by maybe running a cloth over it. And what happens is you need to bring this rod toward the actual object. Now, when you bring it toward the object, it causes it to split up. It causes the electrons to all go over here. Because there's electrons here and electrons repel each other. So the protons in here are going to move here as all the electrons. Now, what happens is this. All these electrons are sitting here, right? It's pushing them away. Well, when it pushes them away, suddenly you connect a wire to it, you would do what's called grounding it. You ground it. And all these electrons want to get away from here. They're still being repelled. So they go down this ground or this wire. And they're all gone now. It's still not touching, though. It's still close nearby. And then when you remove this, suddenly all that's left is a positively charged object. Again, never touched it. Okay, you never touched it, but when you connected this grounding, all the negative charges flowed out. Then once you take this out of the situation, you have a fully positively charged object. Now, while induction was used to charge a conductor, polarization is used to charge an insulator. And the way polarization works is, in the presence of a charged object, right, here's your charged object, the insulator's molecules realign themselves, because all the molecules inside of an insulator are polar. So they have a dipole. So all the negative poles end up pulling themselves toward the surface, okay, towards the surface. And now the insulator has no net charge, but it does cause it to actually pick up different items, like paper, for example. If this was the charged object, this is the non-charged object, they're going to want to move and attract each other this way, so it causes the comb to pick up the little particles of confetti or paper. This is polarization when you're charging an insulator temporarily. Again, no net charge is involved, and there's no contact really necessary for this to happen.